Hey guys, this is Isaac again here with another tutorial. Today we have a problem on momentum and the separation of objects. So here I have a stick figure. He's a man and he's standing on ice and he's holding a bow and arrow. So he's aiming and preparing to shoot this arrow in the positive direction. So I've denoted some values down here and I'll go over them. The weight of the man plus the bow all combined is 60 kilograms. The weight of the arrow itself, just the arrow, is 0.500 kilograms. The velocity of the arrow after it's shot, after he shoots the arrow, is 50 meters per second in the positive direction. The coefficient of friction, and I missed to write that as a mu, the coefficient of friction there is going to be 0 because we're just standing on ice, so we're going to pretend it's 0. And we want to know what is the velocity of the man with the bow after he shoots the arrow. So after this man shoots the arrow, there's going to be some force counteracting that, and he's going to move slightly towards the back. So we're going to dive right into this problem by writing our equation of momentum. So I'm going to write the momentum is equal to the mass of the man, and I'm going to write that as m1. So the mass of the man times the velocity of the man, I'm going to put that as a m1 v1, so the man is equal to m1 v1, plus the mass of the arrow, I'm going to put that as m2, times the velocity of the arrow, I'm going to put that as m2, is equal to the mass of the man after he shoots, plus the mass of the arrow, and the momentum of the arrow, after the arrow is shot. So, in other words, this side of my equation represents before the arrow shot, and this side represents my momentum after arrow is shot. So I'm going to plug in my numbers. So the mass, I'm going to work on this side first. So the mass of the man here is 60 kilograms. The mass of the man in the bow, 60 kilograms. My velocity is 0. Plus the mass of the arrow, which is 0.500. And the reason why the velocity of the man is 0 is because before he shoots the arrow, he's not moving. The same thing goes for the arrow. My initial velocity of the arrow is also 0 because before the arrow is shot, it has no momentum. So all of that is going to be equal to the mass of the man and the bow after he's shot. So times the velocity of the man after he shoots, which we don't know, plus the mass of the arrow. So the arrow is 0.500 kilograms, and the velocity after the arrow is shot was given here. It's going to be 50 meters per second. Right? So this side, my left hand side, is going to be equal to 0. So I'm going to get a big 0 because 60 times 0 is 0. 500 times 0.500 times 0 is 0. So 0 is going to be equal to 60. Mass of the man times my velocity 1 after the arrow is shot. So this is denoting the velocity of my man plus 500 here times 0.500 times 50 here is going to be equal to 25. So now I have to move this 25 to this side. So I'm going to move my 25 here. I'm going to have minus 25 equals to 60 and the velocity of the man. So I'm going to divide by 60 here, and that should give me minus 25 divided by 60 is going to be approximately, okay, well, let me write this. So that goes out. There's going to be approximately minus 0.41, so that should be a 1. 417 meters per second. That is equal to the velocity of the man after he shoots it. So what this is telling us is that after the man shoots this arrow this way, his velocity is going to be of man is going to be equal to 0, so minus 0.147 meters per second in the negative direction. And that makes sense, because it makes sense that we get a negative answer, because we know that the man is going to be moving backwards. So that is it for this problem. I hope you guys enjoyed it. If you have any questions, please leave them down in the comments. If you know anybody else that needs this type of help, so share this video with them. Thank you.